Hello everyone, welcome to this talk, Bungee Jumping into Quarkus, Blindfolded but Happy, in which I will share with you my experiences developing with Quarkus. If you have any questions after this talk finishes and after the Q&A finish, or you want to share your experiences too, you can find me on Mastodon at Delaware.flow.social, or you can find me on Twitter as Delaware, but you will find me faster on Mastodon, that's true. The first thing I want to do is introduce a bit of myself. I have been a free and open source developer my whole career. I have been very lucky on that aspect of my life. And in 2019, I joined Red Hat. I joined the middleware integration team, in which we use Apache Camel mostly to create architectures or to create services, integrations, orchestrations of different services. And I'm a Java developer, I'm a Java champion, and I have been working with Java my whole life. And at some point, I decided to try Quarkus. And some of you may have noticed, and it's true, that Quarkus is mostly led and developed by Red Hat, and I work by Red Hat. And you may think, well, this is just a commercial, technical marketing kind of talk. Well, the truth is, Red Hat is very big, and I work for a completely separated and independent department. I'm using Quarkus not because I was forced to for company reasons, but because I thought it was a good idea to use Quarkus. And my experiences here don't reflect any company interest or anything. It's just that I liked what I discovered with Quarkus, and I want to share it with you, and I'm going to share you the goods and the bads. And well, there are more goods than bads. That's why I'm happy using Quarkus. Why I started using Quarkus? As I said, I work for the middleware integration team, and 3 years ago, mostly 3 years ago already, I started this project, How2.io, and it's a low-code, no-code. You can drag and drop in a Scratch-like way to create the integrations in Apache Camel. You can see the source code being generated on the left. You can see the canvas on the right. And for the backend, the one that generates the source code, that converts the source code to something that the graphical side may interpret and draw in the canvas, we decided to use a Java backend. And at some point, at the beginning, I thought that it made sense to, this is a new project, this looks easy, let's try to use Quarkus because Quarkus looks cool. And they say it's good for serverless, we want this to be serverless. It's cool for being fast and have low footprint, let's try that. And to be honest, I just jumped into Quarkus, completely unaware of anything. I didn't read any documentation. I did as most of us developers do. I see a new framework or library, I like it, I just add it as a dependency and start hitting the keys and see what's happening. And a lot of things happened. So before I started this project, I was mostly working with JDK 8.9. We were migrating to 11, a bit of 11, that's true, in the latest years. But it was regular Java, normal, basic, vanilla Java, Spring. Maybe it was on a very imperative way of working, blocking, synchronous. Usually we just generated a Word file, we deployed it on Tomcat, cross fingers, everything is working. What's serverless? That's a buzzword that doesn't mean anything. So we started How2, and at that point the Java version that you should, it was still on beta, the JDK 17, but it was closing to being a long-term release. So I started with JDK 17, which is a big jump. I added Quarkus. Quarkus forced me to start doing more reactive code. We also jumped into the Knative deployment because we wanted this to be something that you can deploy in a cluster, in a Kubernetes cluster, be serverless. And we wanted that to be part of the building process, not something that you do afterwards, like, okay, I generate a war and I have to create a Docker image that throws this war somewhere, blah, blah, blah. No, I wanted to be as native as possible and still uses Java and Quarkus. And I know this is Java conference, so this is kind of a silly question, but I think this is interesting. I added this slide for another iteration of this talk. And it was not a Java audience, so I added this. And it's true that Java is not the most used language right now, although it's growing. And there's millions of developers and billions of active JVM for 2024 estimated. But the interesting thing is that we have there Python, C++, C#, Java. And if you compare the energy efficiency of programming languages, you see that, well, Python is one of the most used languages, but it's very on the less efficiency language programs. And it's true, Java is not the most efficient, but it's close to C++, Rust, and then C. But, well, why worry about this? Well, I worry about this because energy efficiency means how much do I pay for my cloud VPS or my cloud CPUs running. The more efficient is my program is, I have to pay less. So obviously I'm interested in this. But what I wanted to say is that this diagram, which shows Java is performing good, pretty good. It's on the right side, on the most efficient languages. This is about the classical vanilla Java. This is not the native Quarkus version of Java. So if you compare the Java, the classic JVM in Quarkus, with different frameworks, this is, I didn't find what legacy framework was this, but we can imagine it's probably one of the most used frameworks in Java. I dare not say any name here, but you can see how Quarkus is much more efficient or uses less energy for the same program. It's especially when you go to the native. It's very, very really the memory footprint and the resources it uses is very, very optimized. How does Quarkus do this? If we are just writing Java code and it's the same code, why is Quarkus so efficient? Well, the thing is, the idea here, the idea here is this is part of what GraalVM uses. GraalVM is another Java virtual machine, and it allows you to optimize a bit your compilation and your build package. So not optimize the moment of building, but optimize the output of the build. So Java is your program based on Java is much more efficient. So in the classic way of how a Java build works, is how it's shown on the top. You have your classes .java, you compile them to .class, add them to a zip file which is called .jar because that's how we work, or .war, but it's a zip file in reality with all the Java classes and the metadata info to be able to deploy it. And then you put that in a Java virtual machine, and the Java virtual machine reads all the classes, loads them in the class path, then start doing things like, okay, I have to inject this bin here, this other bin here, I have to populate this, I have to blah, blah, blah. And does a lot of things on startup time before it can really run, which is the last step. And this was good on a desktop type of environment because you don't care if your application takes 30 seconds, 1 minute, even 2 minutes to run. That's fine. And it allows you a lot of flexibility and dynamic configuration and dynamic way of loading. For example, you can add more jar files. After you build your core, you can add more jar files as plugins, and all of them will be on the class path, so you can do magic and say, oh, if this plugin is loaded, then I want the application to do something different. And it's very flexible, but seriously, do we use this in the day-to-day? We don't really use this much or that much, especially when you move to the cloud. And again, in the cloud, you want to be cheap. You don't want machines running for a long time. And if you want serverless, if your application takes 20, 30 seconds to start, That's crazy. You don't want 30 seconds to start a serverless application. You need a serverless application to be fast, to milliseconds. We should be talking about milliseconds, not seconds. Even if you have a very light Java applications that takes 1 second to start and answer, that's still not serverless. It takes 1 second to answer. You cannot have it shut down and then when that request comes, put it up and answer. You need it to be running already, so you are wasting resources. What does Quarkus do, and what does all these ahead of time virtual machines do? Well, you try to package after you do a lot of optimization, like I read all the classes, I build the class path, and then I start searching for things like, here, I need to inject a bin. Which bin is it going to be? This one. I inject it directly. No, I don't wait for runtime to inject the bins. I will do it on build time. So all this searching where each bin goes, it's done on build time. If I see that some classes are not going to be used because no one is calling them, I just remove them from the jar. Maybe I added a dependency, maybe I added some utility dependency that has a lot of classes, but nobody's calling half of those classes. Why are they being added to my jar file? And why are they being added to my class path on runtime? They're just wasting resources. If I see, even inside one class, if I see some functions that they are not being called by anyone, I just remove them. If no one is going to use them, why are they wasting my resources? So the jar generator is much more optimized, and it does a lot more optimizations. I'm not going to mention here because I'm not a Quarkus expert, I'm a Quarkus user, so I prefer not to enter into those details, but seriously, it does a lot of optimizations that way. Everything that can be done on build time is done on build time, which has a disadvantage. You don't have this dynamic magic happening. For example, if you want to the classic, I'm going to load here or inject here all the bins that implement this class, this interface. If you try to add more things to the class path after you build, like I want to load these other class files inside this bin, that's not going to happen. You cannot load things dynamically. You cannot do reflection, because if you try to do reflection, if you call a function only by reflection, when you do this build and this searching what is not going to be used, I'm going to remove that function. So reflection is tricky. Quarkus does not allow you to do the reflection, but again, how many times do we use reflection in 90% of our applications or services? And usually there's better ways to do it than reflection. So this is what Quarkus do. Quarkus has a much bigger build time because it's huge. It takes a long time because it checks a lot of things, try to optimize a lot of things, cut and remove a lot of stuff that is not going to be used. But then the startup, we are talking about milliseconds. I mean, seriously, the startup time is amazing. You can move something that takes several seconds to start, and then when you move to Quarkus, it's milliseconds. In Kaoto, we are loading remotely. We have configurations that are loaded remotely, and for example, the kind of pieces or steps you can drag and drop into your workflow to build the workflow, those steps are loaded dynamically based on remote catalogs. And even then, even loading things remotely and having to parse, I think it was close to 500 different files loaded, parsed, and added those steps into memory collection. I think it took less than 300 milliseconds, and seriously, 500 files that are not locally, but you have to download. So it's amazing. The speed and the low footprint that Quarkus has is amazing. I don't want to go back to normal Java anymore. So let's talk about pros and cons a bit. It's incredibly fast. I haven't said this before, right? It's incredibly fast. You cannot believe this. The startup time is amazing. Also, the dependency management is opinionated but very easy, because usually what you do, maybe I should open here another. So when you go to the Quarkus website, I should have loaded this before I start recording, but this is me. You click on start coding, and then it shows you a lot of dependencies, Maven dependencies that are already Quarkus prepared. So for example, of course, you have Hibernate. You have Hibernate here. You have things to be able to be reactive. You have many kind of dependencies. And why I say it's opinionated? Because as you cannot use reflection, as you have to be careful about certain things on how to develop for Quarkus, not all the libraries will work out of the box. Not all the frameworks will work out of the box. But these are the ones that are already prepared for Quarkus. I have used libraries and dependencies that are not for Quarkus, and they work as long as I don't do any weird magic. And the thing is, it's opinionated in the sense that this list of official extensions or dependencies that are added to Quarkus are carefully chosen, so they go with a good set of guidelines on how to create good software using Quarkus. It's reactive. Imperative, you can also do imperative stuff. We will see it later, but it's mostly reactive, which is a very good way of developing. It's very native to Kubernetes. I mean, you can generate automatically and deploy, and with the same Maven Quarkus command, you can deploy things, you can configure it to generate the images. It's very fast. It also contains native compilation. It's not only that you can generate a JVM that runs on GraalVM. You can generate a jar that runs on GraalVM that is very optimized and everything, but it also has this option to compile to native, like you will compile a C or C++ application. So you don't need any JVM. It's even faster. It's much faster, but it's true that usually Java virtual machines have optimization. So if you want to run something for a long time, like weeks or months, that application is not going to stop. It's not serverless. It's just going to run for a very long time. Sometimes you have to check. Sometimes the native in the long run is not as optimized as the JVM version, but still, especially if you want serverless, the native version is very fast. Then you can do live coding. There is a Maven Quarkus .dev in which you can your service will be running, and then you can keep developing, and it will hot plug your changes on the running application, which means that you can also develop faster. You can see on real-time changes, which you can always do this kind of with normal Java development, because you can stop and start, but if it takes several seconds to stop and start, you're losing time. It's not much time, but you're losing time when you assume all the time developing that you have to wait. Then you have things like, as I said, very good design patterns on how you should implement things. You're not enforced. You can do crazy stuff here. You can do chaotic stuff, but it tries to teach you how to use them, and they make sense. Stupid things like if you're developing a HTTP endpoint, you should have services that run the code and run what the endpoint is going to do, and then you have the endpoints calling those services. So you have separated the logic between the end of the endpoint and the parameters from what is really happening on the service. Stupid thing. You are not forced to use those design patterns, but if you do them, if you use them, then you will have a much easier time. And then 1 year ago, there was no possibility to debug in native mode, but now you can also debug in native mode, meaning if you do the compilation in native mode and you are running not inside a Java virtual machine, but as a normal application in native mode, and you have your IDE open, you can also debug and see step by step, line by line, what you are doing, what the native application is doing, and debug, which is nice because sometimes the native mode had bugs because you build it badly, you mess up with the build, but let's see. So the native mode has issues that you don't see on the Quarkus.dev. And the cons, well, it's a fancy state of the art, which means sometimes it happened to me. This happens less and less. I haven't seen this in a long time, but sometimes you reach something that is not yet done, which is a pro-con, because yeah, it's fancy state of the art, you're using the latest things, sometimes you just reach the border of what is developed and fall to the other side, but then you can help them. I mean, this is open source. You can decide and help them, guide them to implement this thing that is missing, which means you can help define how it's going to be done, so it will fit your use case better. And the biggest con is there is no reflection. You can inject pins, you can do a lot of things, but there is no reflection, which I'm pretty sure most Java developers have never in their life used reflection directly. Maybe they use it in some libraries. I'm pretty sure Hibernate uses reflection, but well, you have the Quarkus version of Hibernate, so you don't have to worry about that. They fixed that, it's working. And now, one big thing, Quarkus just released the version 3.0. Was released in ending April, but this is pretty new still. And it contains many things. It's not only that they have, it's better, faster, optimized, blah, 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 of course, as each version, but it has some interesting stuff, like the packed contract-based testing capacity or capability. This is interesting because they added a packed for testing. I don't know if you know what packed is and how this works. Holly has a very nice talk about this on Quarkus Insights, which is a YouTube channel. And it's just when you have different microservices, sometimes when you do the end-to-end tests, they fail because something changed in the contract of one API and the other does not reflect that change in the contract, in the how they interact with each other. So packed just makes sure that the contract doesn't change. You define the contract this endpoint is going to always return this type of object, and this type of object contains this and this and this and these attributes, and this attribute can never be null, these kind of things. And so if you modify the API, that packed contract test will fail and will notify you, hey, this is failing. You have to make sure the rest of the microservices reflect that change, because if not, they're going to be broken. Then they have also added in Quarkus dev services for Kubernetes, which is so you are working in the cloud, you are using a cluster, you are interacting with the cluster, maybe deploying pods, reading stuff, doing service discovery, whatever. The thing is, for dev purposes, you don't usually have a cluster nearby to test, or you have one but it's dirty with development testing stuff. So Quarkus already gave you the ability of the smartest containers, which was already in version 2.0, which allows you to run a Kubernetes cluster on the fly for testing, but not for the dev mode. The dev mode is this mode I told you before, that you have it running, you are developing, and the changes are hot plugged. So what this does is just, okay, when I run the development mode, I want you to also start a cluster based on Docker. It's similar to Kind. So it's very simple, but I can use it, and it's going to run as long as I run my application. And if I have different microservices and I need all of them to run the same cluster or to work with the same cluster to see how they interact with each other, it has also the option to have service discovery. So if there is a Quarkus application already done running in dev mode with a Kubernetes cluster, then the other Quarkus application that starts in dev mode, instead of creating their own cluster, it's going to use the cluster of the other application. So you can see how they interact with each other, which is a very clean way of working when you are developing in your laptop, and you don't want to connect to an external cluster, or you don't want to worry about having a clean cluster that runs. And also, well, they updated the Jakarta EE, the Eclipse microprofile, and added the Jakarta EE APIs to Quarkus. So what does this mean? Quarkus uses standard APIs and standard annotations. So it's remember the old times of Spring. Spring allows this kind of annotations already, but remember the old times when Spring had their own annotations for auto-wire instead of inject. It's kind of stupid. But the thing is, when you had to move to another framework, you had to translate all that. If you use the standards, you can change the framework, and it's going to be it's supposed to be the same behavior, because the definition of what inject means, for example, or what startup means is generic, is not tied to your framework. So let's see a bit of my messing up and mistakes with Quarkus. One thing I didn't mention, but it's interesting, is that Quarkus have a developer console dashboard by default. So when you run it in production, you don't have this, but when you run it in dev mode, you have an endpoint. I think it's 8080 by default, but don't mind. One endpoint in which you have this kind of developer console. And this has, depending on which extensions and dependencies you're using in Quarkus, you will see different blocks here. This is, for example, this helps you change configuration on the fly on the config editor. This also allows you to check which bins are loaded and the properties of those bins, which is interesting when you're running an application, is not behaving as you expected, and then you discover, well, you're injecting the wrong bin in the service, so it's doing the wrong thing. It's not wrong, it's just you did it wrong. But yeah, Quarkus is always right. So there's a lot of things, and depending on if you're connected to a database via Hibernate and these kind of things, you can explore what is happening on the fly without having to stop and debug to see what is happening. And of course, the kind of information depends on which dependencies and extensions you're using. The first thing I learned in Quarkus, because what I did, as I told you, I didn't read any documentation. I just go to the Quarkus IO, start coding these dependencies. Boom, I have the hello world, it works, I'm happy. Let's start working on my real project, right? No, that's not how it works. Because the first thing I did was create a Maven multi-project, and I start working, everything was working fine. I have the domain package, I have the service package, I have the endpoints package, I have this kind of, domain-driven design. And I have separated projects, everything worked fine. Let's try the native mode, Quarkus dev. It worked until I compiled to native, and it didn't work. Why? Things were not, I was doing as in the Quarkus hello world example. Why is this not working? Why suddenly things are not there? Substitution target. Not loaded. Why is it not loaded in native mode? Well, I was stupid. Remember when I told you that on build time, Quarkus does a lot of optimization and removes all the classes and functions that you are not directly calling, explicitly calling? Well, if you have a multi-Maven project and you define here classes that are going to be used on this other project, but no one used them on this project, when you compile to native here, all those classes are removed. So by the time you reach here, those classes don't exist. Well, no problem. The problem is you don't compile native here. This is the domain package. Why are you packaging in native? You go to the last one, the one that generates the jar, the war, the whatever, and that is where you do the native compilation, and that's where Quarkus does all the trimming and all the cleanup. Makes sense? But until you hit this wall, you don't realize this makes sense. Don't be me, please. So everything was working fine. I was doing the native building only at the end, and I start injecting things. And then some of the beans injected worked, some of the beans injected didn't work. Why? Because for some reason, the native compilation at the end was not reading all the beans in all the projects and injecting in all the projects. It was only doing it in the end. Why was it doing it only in kind of ignoring all the injections before the last project? Why? Because, well, it didn't realize there were injections and beans in the previous projects. Oh, this is a problem because, hey, what problem? You just add a Yandex index, which will map and index all and list all the beans available in all your projects. So when it reaches the last one and it does the native build, it has a list of all the beans, a list of everyone that wants things injected, and it works. That's it. Then we have things like, I was talking about injecting things. Quarkus have a Arc, which is a CDI that works very nice with Quarkus, and it has all the Jakarta EE and microprofile annotation. So it's pretty standard. You have the pre-destroy, post-construct, inject, application scope, singleton, all these kind of annotations. Nice and easy. Sometimes, well, you can also you don't need to have a getter and a setter for each, a setter for each inject. You can inject several beans on the same one. And notice that this is resolved on build time. So you remember when other frameworks, you run something and then on runtime it says, I can't find this bean, or I have more than one bean, I don't know which one to use. Well, Quarkus does this, but on build time. And note the startup. That also means, hey, maybe no one is calling this this bean yet, but when we do the startup of the application, please create it already, because let's warm it up while other things are happening. This is one thing that was not fully supported by the moment by the time I wanted to implement it, which is polymorphing and marshalling. Marshall and Marshall, you know, I have several classes that inherit an interface. I have an endpoint that receives this kind of interface class-like thing. How do you deserialize based on the type? Well, you just do this, and it works. There is a much simpler way of, you don't have to explicitly define the JSON subtypes. I have a JSON type serializer and serializer, blah, blah, blah. In normal Java, well, in Quarkus you need it, or at least I needed it by the time I did it. Note the register for reflection. What does this mean? This means, this is kind of a side note to Quarkus. Quarkus, I know no one is explicitly calling this class. I know you want to put it on the trash and forget about it and delete it forever. But trust me, you're going to need this on runtime. So don't remove it. Register this, because this is going to be used. This is a nasty trick, but it works. So yes, reactive. I mean, I wasn't used to work with reactive. I messed a lot because everything is reactive, which means I have a REST API, and I want to, I have a big main thread in which all the requests come, something gets done, and then I have a response. If I have a big processing here, it gets blocked. Or if I start doing things asynchronously, it starts doing things wrong. So make sure you know you're reactive before you start doing things. What if my endpoint returns a slow response? I'm blocking the main thread because it's a main thread that takes the query, the request, does things, and what if it's a slow response? Or even worse, a stream. I wanted to stream a log, which means I wanted to have a connection that never finishes unless the customer, the client, closes it. So what do? easy. I just tell blocking. I don't know if you see the annotation blocking. It's there. This is blocking, so don't do this on the main thread. Stupid again. Easy. This is the way it's done. But if you don't read the documentation, you're like me, you mess up. So please read the documentation. Tests. You can run tests in native mode or in JVM mode. And as I told you, there's many things like running a Kubernetes cluster on the fly, test containers that are very smart. But also we have here the test HTTP endpoint, which means integration resource defines an HTTP endpoint, and it has a URL. Well, I'm telling Quarkus that you have to start these tests, and you see there I do a request given when blah 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 content type post slash something. This slash something is part of the URI that goes after the URI defined on the integration resource test. Please map this. So if at some point integration resource test change the URI, I don't have to change the full test. I'm just changing the last part. The smartest containers, Kubernetes, but not only databases, messaging. It helps you because usually you don't care what password port, whatever is being used in testing. You just want a database and connect to it. Well, Quarkus automatically configures these kind of things on the fly automatically without you having to explicitly say things. You can also explicitly say things, but you usually don't care. So all this configuration port, host, version, blah, 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 they are automatically generated, or you can configure them in properties and everything is automated. It's test containers, but smart. As I said, you can always set with Kubernetes test server, which means please, when I run this test, I need a Kubernetes test server. Create one for me. It's going to be empty. It's going to be very simple. It's going to be plain, but I will have a Kubernetes server there for me to use it. Also, always keep Quarkus upgraded. Don't be me. What does this mean? This means this is something that I found. There was something that was not a bug, not yet finished developed, blah, blah. As you can see, the response was pretty fast. This was on Zulip, the open chat of Quarkus, and they answer and fix it very quickly, and they say, hey, do you mind if we wait for the major version or something like that? I say, don't worry, of course. We can wait. And then I several months later, I say, hey, why is this not working? I kind of remember we fixed this, but this is not working. Why is this not working? Well, because obviously I forgot to update. And updating is pretty stupid because usually all the dependencies of Quarkus, the libraries, the dependencies I showed you on the quarkus.io, start coding, the list of dependencies, most of them use the same version. So if they go with the Quarkus version. If you have your Maven POM well configured, you just have to change the version and it gets updated. And usually it's very well backwards compatible, so you don't have to worry about that. And this is it. I don't know if you have any questions or anything. You can ask now or you can try to reach me later. I'm open, and remember, I'm not a Quarkus expert. So if you ask me specifics and details about Quarkus internals, I may not know the answer, or better yet, I may have the wrong answer, but I'm happy to share my experience and more details about what I have been doing. Thank you.